Hi. So you remember how we've been talking about parallel lines and all the crazy angles that are formed when we get a transversal involved? Well, there's even more for us to discover, not just the relationships between the angles, whether they're corresponding angles or alternate interior angles or alternate exterior angles. We also can look at the size of these angles. So today's lesson is called Size Relationships Between Angles Formed by Two Parallel Lines and a Transversal. Another long title. Let's get to it. So remember, when we have two parallel lines, we have created a few different types of space. We have the interior space, which is the space between the two lines, and the exterior space, which is on either side of the parallel lines. So what we're going to do is we're going to color in our spaces with different colors. I'm going to color my interior blue, a light blue. And then I'm going to color my exterior in, let's see, what is this color called? Magenta. I'll color in magenta. You can pick whichever two different colors you would like, though. So here we've just got our plain old parallel lines. I want to draw my transversal here with a thick purple line. Our transversal, here, let me get me a ruler so it's a nice straight line. I can fix that, make it a nice chunky line. So it's very clear to see where my transversal is. So now I'm going to highlight the amplitude of one of the angles, like this. This is the amplitude of one of our angles, right here. So now, can you color the amplitude of a corresponding angle with the same color? Well, if I remember what corresponding angles are, I remember that this is an example of a corresponding angle. So now I'm going to compare some sizes. You could use a protractor, but I'm going to get out some other materials for a different fun way. I've got some scissors, and I am going to cut along the transversal and the parallel line. So along one of the parallel lines, and then along the transversal. And then from here, cut or tear. Not often you're told to tear up your work, are you? So I'm going to compare this angle right here to the other angles I see. Is this angle the same as this one? Nope. Is this angle the same as this one? Oh, it is. Interesting. Let's keep going. Is this angle the same as this one? No. Is this angle the same as this one? Yes. Interesting. Is this angle the same as this one? No. Is this angle the same as this one? Oh, yes, they are. And is this angle the same as this one? No, it isn't. Interesting. Interesting. So let's look at another one of the angles that our parallel lines and transversal have created. Let's look at this one. So I'm going to get out a different color, and I'm going to shade in the amplitude of that angle. I'm using a deep blue navy color. So this is the amplitude we're looking at right here. So we're going to cut along the parallel line. Oops. And then along the transversal there. And then I get to do what I don't often get to do to my work. Tear it up. There we go. I've got my other angle. So let's compare some angles. So is this angle that I just tore out the same as the other angle that I had torn out? No, it's way bigger. What about this angle? No, it's also bigger. This one? They are the same. Interesting. Now, is this angle the same? No. Let's keep going. This one? Yes, these angles are the same. What about these two angles? Nope. And our final angle right here, are these the same? They sure are. Very interesting. So now these two angles we found are of different measures, right? Interesting. I'm going to cut out another angle on this side and compare it to the rest of the angles. Now you might be telling yourself, well, wait, Miss Christine, why are you cutting that one up? That's the same as this other angle, right? So isn't it just going to be same as all the other ones? Well, yeah, you're right. Thanks for reminding me of that. That saves me a bit of time. So what do we see here? How can we describe what we've learned? Well, if we remember our terms, corresponding angles and alternate interior angles and alternate exterior angles, let's write down what we found. So when it comes to corresponding angles, which, as you may remember, are the ones that are right here and right here, because they are on the interior and exterior. They're on different parallel lines, opposite parallel lines, and they're on the same side of the transversal. So, oops, camera. All corresponding angles are equal. So I can write that. All corresponding angles are equal. Now what about our alternate exterior angles? Let's look at those. Now which were those again? Ah, yes. Those were the ones that are in the exterior space. So we know our exterior space. They are attached to opposite parallel lines and are on the opposite sides of the transversal. So what did we find with those? Well, they're equal. So I can also write all alternate exterior angles are equal. Now, what about our alternate interior angles? Which ones were those? Well, we know that they're in the interior space. They're on opposite parallel lines. And they are on opposite sides of the transversal. So what do we see about those two? Well, remembered that this angle is the same as this exterior angle. And this one was the same. So, I can write now that all alternate interior angles are equal. Interesting. Now, if you remember also, we've talked about the relationships that different angles can have. Now, if we were to look at, for example, this angle here and this angle here, we might remember that those are supplementary angles because they create a 180 degrees straight angle when put together. But do you remember what I would call this angle and this angle? These two? Those those two angles share a common vertex, and that's what we call vertical angles. What do we notice about all the vertical angle pairs? Well, these two, and for example, in these four angles, and these two are equal. So all vertical angle pairs, I should say, are equal. Fascinating. Well, thank you so much for joining me as we explored the size relationships between angles formed by two parallel lines and a transversal.